Hey, and welcome back. In this session, we're going to cover maps geolocation and geofencing. We've got a little bit of time and a lot of cool demos, so we're just going to go ahead and get started. So we're going to cover the following four topics: launching mapping applications, and so this is going to be launching them from our own application into another application. We're going to be programming the map control, putting elements on the map control and making it look the way we want it to look. Then we're going to look at the location APIs. How do we get the location of our device? How do we track the location of our device, update that location? And then the last one is the very exciting geofencing, where we can use a very lightweight background task sort of geofencing API that is a great way to run location-aware applications in the background without using a sort of really resource-intensive background task that we would have been using in Windows Phone.
It's really
Windows
cool.
Phone 8.
Yeah, cool stuff.
Yeah. So start with launching mapping applications. And this is just a mapping URI scheme, and it'll launch to I guess the first version is a mapping URI scheme that launches to Bing Maps. And this can be used as a cross-platform, used on Windows Store, Windows XAML apps, and it uses all of the same parameters. And it's really, really simple. We just create a new string, and we give that string a URI scheme and some parameters, and then we push it to our launch URI async. So the first URI scheme we can use is this Bing Maps. You can see here. There are a lot of really cool parameters that you can use on this. The CP stands for the center point. Where do we want the application to center around? We can we can define the zoom level. We can define a bounding box, which is, I believe that's new for 8.1. But it's basically you just give it 4 points, and it does its best to fit the map around for the best view for that sort of box. We can show traffic with the TRFC. We can actually point out a collection of elements, of points by giving it a collection. And then we can do queries and where. The difference between where and the where parameter and the queue parameter is that the where parameter is a search term for a location, and the queue parameter is more of a query term specifically for businesses or locations that have names. Lastly, we can actually go out and tell Bing Maps, hey, I want a route to a point, and it'll start mapping that route to that particular point. We can also do URI schemes that will kick us out to third-party applications. And we can do that using the ms-drive to and ms-walk to. This will give us a driving route or a walking route from destination 1 to destination 2, or we can just give it one single destination, and it'll push us out to, it'll go from wherever we happen to be out to that destination. So I want to show a little demo about that. It's pretty fun. And one more. There we go. Okay. So we're going to launch this up on a device. And we've got a couple of hit points, and we'll just walk through those as we show what they do. All right, here's our device. So we can launch the Maps apps, we can launch the driving directions, or we can search for a place. So I'm just going to launch the maps. We've got my center point is, I wonder where that is, and a zoom level of 17. So we hit F5 to run that. You see, that seems to be, that's the Microsoft campus.
Oh, there you go.
So there we are. Right on Microsoft, you can see we've just launched the application, centered it to about where we are. We're actually at a different studio. But we'll go backwards and we'll launch our driving directions here. You see, this is the MS Drive to. So this is going to launch that third-party application experience. F5. And you see, this can actually, if you don't like the Here navigation, if you don't like the AT&T Navigator, you can download other applications, and other applications, your application, could subscribe to this MS Drive to URI scheme. And then you'll actually get a pile of applications that say, hey, I can handle driving directions.
Yeah, the same thing happens on Windows tablets and PCs.
Yep. And this is a cross-platform, sort of thing. So we can do this. Yeah, this is where we actually are, and this is a driving directions to the Microsoft campus.
Hey,
look at us.
Because we're actually in Redmond Town Center.
Right.
Interested.
A little ways away. Right. But you can see we've got traffic on there, and I think we can actually turn that on or off. So we'll go back to our application, and we can search for a place. It's a little bit early still for me, so I'm going to search for coffee. You see, we're pulling up Bing Maps. We're giving it that center location with a new level and a query with the search term that we've just put in there. So we launch it, and it just gives us a whole bunch of places around here where we can go get sweet coffee. Right. So that's it's actually a really flexible way of integrating maps into your application, and it's really helpful if you don't want to maintain just that full-on mapping experience inside of your application. Just kick them out to another mapping application. It's
really valuable.
Oh, it's super valuable. Yeah.
You get a load of great functionality for free, effectively.
Yeah. And with the queries, you can really kind of define exactly the sort of views that you want. So the queries and the routes. It's really powerful, and it's really easy. So, okay. Now we're going to talk about our runtime maps control.
So this is where you're writing your own mapping. So
right. You say I don't need any help. I can do this all myself.
Or the URI schemes, they don't give you what you need. So.
Right. So there are a lot of map controls across all of the different Windows platforms. If you're working with Silverlight 8.0 or Silverlight 8.1, you're using the what is effectively the Here Maps control. It's in the namespace Microsoft.phone.maps.controls.map. If you're using Windows Runtime Phone 8.1, and that's what we'll be showing here, you're using windows.ui.xaml.maps.map control. And then if you're using Windows 8.0, 8.1 store applications, you're using the bing.maps.map. So in the next demo, and I could have shown it in the last one, but in the next one, I'll show a little bit about how we can write an application that hits the phone runtime maps control and the store maps control, and try to see how we can get those to work together.
So there's a few differences, it has to be said. There are differences between working
yes, there are. Yep.
But with careful design, you can work around these things. And you've got a sample that does that.
Yeah, and we'll show that off. Yeah. So, okay, so what's new and different in Windows Phone 8.1 mapping? As we said, we've got the new the maps control. There is a significant API change. If you have been building mapping applications and geolocation applications in Windows Windows Phone 8.0, there are going to be some substantial updates. But along with those updates, we get cool stuff like we get geofencing. We have a simpler, more consistent geometry. This is actually really exciting. We'll get into this, the map icon, which instead of drawing on top of the map in sort of a heavy XAML sort of way, we're actually integrating in with the native mapping render control, so it gives us a lot cleaner, a lot faster experience. But we can still do XAML objects, and we can put them into our map control.children, which makes them bindable. And this is new from Windows Phone 8.0, and that's really valuable. It's nice to have binding back in the applications. Finally, we have improved custom tile source support. So if you don't like any of the tile sources that we provide in the map control, and you say, I've got a better tile source for that, you can take that tile source and apply it to the map control and effectively create your own map. So all the ways to display your content. There's two big ways to do it. The first one is pins, and the second one is shapes and tiles. The pins category has these XAML objects that we've attached to the map, and then the map icon objects that are native rendered. Very high performance way of displaying images and text, but not interaction. It's basically just those images and texts. In addition to pins, we've got these shapes and tiles, and the shapes are vector objects that are rendered onto the map. We can render these polylines and polygons. We can render full routes, or the tile source that I mentioned earlier, traffic on top of the maps, and as well as extruded buildings that you see in the right-hand visual there. So. With XAML children, we've got the XAML items control is where we're going to shove all of our XAML children in order to make sure that they show. The way that we get our XAML children to show up at the right place is a couple of attached properties. The first one is mapControl.location, and then we can give it a geopoint. And this just says, I want the object to be right here. And then we can give it a normalized anchor position. Now, the way a normalized anchor position works is it's essentially you view your entire control as a 1-by-1 grid.
We're talking about the icon.
Right.
So a 1-by-1 grid, yeah.
Right, so the icon that you see there, let's say it's a XAML element. And it's got a vector and it's got some text, and maybe we've bound to that text somehow. We don't want the geolocation to be up at the top left corner, which is where it would be by default. So we can take that normalized anchor position and say, I want it to be x equals 0.5 and y to be 1. And that's going to take that normalized position and say, okay, we're going to move to the middle, we're going to move down to the bottom. That's where I want the geolocation to show up, and then render that XAML control around that point.
Yeah, so those little icons you have on that picture, they're kind of round circles with a point, and so the point would be, say, hey, that's actually the exact position where it is. So.
Right, by default it would be 0, 0, so it would be kind of the top left corner.
Left, which isn't the right position.
Which isn't where that geolocation is, right, so. We also have, the map elements. Map elements are drawn by the internal mapping, the native internal mapping system. They're not XAML elements that are laid on top. They're part of the actual map rendering. And that's great, because that means that they're very performant, very clean, and very, very fast. So the three types that we have here are map icons, which contain an image and maybe some text to go along with that image. The map polygons and map polylines. So the map polygons are like the building that you see, the Seattle Art Museum, in that first image. And then the polylines are something like the route that you see in the far right image on the screen. Moving on to tile sources. Tile sources are just tile overlays on the base map.
This has been a big ask, hasn't it, from people?
This has been,
wanted much more flexibility.
There are a lot of developers and a lot of companies that, geolocation and geomapping is a very big business, and it's very important to make sure that that the people who have their own mapping tiles can take those tiles and pull them into the default map control. That way, they don't have to worry about any of the interaction, any of the user control stuff that goes along with it. They can just provide those mapping tiles that they need. One of the coolest part here is the local map tile data source. This is new for Windows Phone 8.1. I think we've always had a version of the pulling those tile images from the web. But now you can save all that tile source to disk and pull it up locally. So you could save all that mapping information, put on your in your local storage, and just pull it up straight from the disk. Lastly, we have the custom map tile data source, which is a bitmap deferral request. And here is what that means, very, very cleanly. You talk to the map and you say, hey, I want you to give me a bitmap, and I'm going to draw on that bitmap. And the map says, okay, here you go. And then you draw on the bitmap, and then you hand it back to the map, and then the map will render that bitmap that you've drawn onto just straight onto the map. So it's a pretty powerful, pretty customizable way of doing this, of laying these tile sources down on your map. Okay, so now that we have that, let's talk about how we actually do this map rendering. At the very bottom, we give you the opportunity to supply that custom tile source for the background replacement of the map. To use this, you'll need to use a special map setting of none for this feature. On top of that, we hand you the land and water of the map. On top of that, we allow you to put another map layer called background overlay. On top of that is the area information, the parks, industrial areas. Then we give you an area overlay in case there's any area information that you want to add to the map. Then we'll draw the roads. Then you draw your own roads. Then we give. Then the map renders the labels. Then you can add a custom foreground overlay, and then finally on top, we have the map renderer draws all those map icons and the map polygons and the map polylines. The XAML renderer comes along at the very end and draws on top of the actual map rendering the XAML controls and children that you've defined inside that map items control. Okay, so let's look at drawing onto a map. Whee! Okay. Here we are. I'm just going to go ahead and run this application. Oh, I do want to make one note. What we're looking at here is actually a universal application, and so this is something that you'll be able. I'm going to focus on the Windows Phone version, but we have the demos for this up, and you can go ahead and take a look at how we do these this drawing on both the Bing maps that we have in Windows and the map control that we have in Windows Phone. Okay, and I'd like to give take this moment to give a. You see, we are in the wonderful area just outside of Amsterdam here.
Amersfoort, yeah.
And I may have to run this again. I don't know. Okay, yeah, I think I'm over here. And this was provided to us by a wonderful MVP known as Joost van Streek.
Very good.
I think I got it.
Yeah.
And he provided some of the mapping applications, and his work is just fantastic. And so I want to thank a big thanks to Joost for his work here. So what we've got, we open this up, we've got lines. We're going to show some lines, some polygons, and some points. And we can see how those work with the native map control. We've created our lines. Here we've got some polygons, and if we tap on it, you see we've got some basic interaction there. And then we can add some points. And this, to me, the points one is really exciting if you're showing a lot of data because, I don't know, we got maybe 50 points here, so I think we need some more points. So you see, this is pretty performant. We got a lot of points. We can see more points the more we zoom in, but the real key is we see fewer points the more we zoom out. And so when there are so many points that it would become really a poor user experience, it consolidates those points and decides to show just a few of them. So that's pretty exciting. It's very performant. It's a great way to show a lot of data on your mapping application. So, okay, how do we show all of that data? Let's take a look here. So first we'll start with drawing the lines. And the key part is right here. We're actually going to get lines from a structure that we have called point list. And then to create a polyline, we create some stroke elements, give it a z-index to say what level we want to show it at, and then just give it a path, a geopath, which is a set of basic geopoints. Then we add that data to. I'm sorry. We add that shape. Yeah, we add that shape to our map element, and this is a pattern that you're going to see kind of a lot. In that we do the exact same thing with our map polygons, where we create a map polygon, we create all the stroke elements, we add a fill color as well, and then we give it a geopath, and we add that to our map elements. And that is the same with drawing points, except that we have a couple more parameters here, text and image, and instead of a set of geopoints, we give it a single geopoint. Now, one quick thing that I want to point out here is that our our getlines gives back a geopoint, even though what we're using is actually a, let's see here, what we're using is actually the position, which is a basic geolocation. So even we're pulling in a list of geopoints, and those geopoints have basic geolocations. Well, why don't we just pull in a list of geolocations? And the reason for that is because Windows Phone uses geolocation, but Windows uses geopoint. And so this data structure creates a list of geopoints, and now that list of geopoints can be used for Windows Phone or for Windows, but on Windows Phone we just dig into that geopoint and get the basic geopoint that we're going to end up mapping.
So it's a composite object that you can use for both.
Exactly.
Yeah.
Exactly. And so that's a big question. Why don't you just use a list of basic geopoints? Well, you can, but if you use the geopoint, it contains the geopoint, and now you've got this composite structure that works across both platforms. Okay, so talked about displaying content on the map. We talked about displaying XAML, data binding small sets of interactive XAML elements. These are going to be slower to render. They're always going to render. And so if you want something a little bit faster, you can do mapping icons. And then we talked about the tile source, where you can display those tiled images. So how do we get our geolocation? The geolocation API is parity with Windows 8.1. This is something that works well across Windows and Windows Phone. It's the namespace windows.devices.geolocation. And yeah, we can use session types for single position sessions or tracking sessions if we want to track that information. We're actually just going to go over this in the code in just a second, so I'm going to fly through it. We use desired accuracy in meters when we want more granularity than the simple default, which is high. And we can use position source to identify how that position was acquired. So here's the actual code for doing this, and this is code for Windows and Windows Phone. We create our geolocator. We say I want it to be this accurate. If we didn't set a desired accuracy in meters, then it would, and it's pulling from GPS. GPS can give you a lot of fine-grained control. So it could be firing off a new geoposition for every time you shift your feet, almost. So then we go into this try-catch. Reason we do that is because if we hit this unauthorized access exception, that's basically its way of letting us know that we haven't requested access in the manifest for doing geolocation. And then we get our geoposition async. It's an async call, so we're not holding up the UI while we're trying to get that geolocation. We give it a maximum age, and this basically says if we've gotten our geolocation in the last 5 minutes, maybe we've got a cached geolocation somewhere, then just use that one. And then a timeout in seconds, the time span in seconds says, try to get this geolocation. If you can't get it in 10 seconds, give up. And then we can pull that information out by getting our geolocation coordinate, latitude and longitude. And then we can, it's not in here, but it's in the demo. We can track the location by subscribing to an event that tracks location that fires off every time the geolocation updates. And this, no, it's in here. Okay, and this is we get that geolocator, same geolocator we had before, give it a desired accuracy, get a movement threshold, and then subscribe to those events. And make sure that we can unsubscribe to those events later on. Otherwise, we'll keep our page alive, continuously listening to these tracking events. So the mapping services in WinRT, these give us, these are basically services that we provide inside of the application to do some pretty fun, cool stuff. First one is simple driving. And we can just call a service and say, give me a route from position A to position B, and it'll hand back this route object. And we can actually create our own route finder that we can then display our own map using our own route, using our own UI. If you think that's the best UI that you can that is available for driving routes. We can get waypoints and traffic with just a simple get driving traffic from waypoints, and we can actually get a route optimization for time with traffic, so we can avoid that nasty traffic jam by taking the surface streets, perhaps. And then finally, we can get routes for walking directions from one place to another. And this isn't a call, this isn't a task we're going out to a service to get it. This is all internal to our application. We can also do these queries to find a postal address for a geolocation or geopoint that we already have. Or we can try to get a latitude-longitude hint for a postal address that we supply. This is not a local places search. You should be sending someone out. If you're going to be doing a serious search, you should be using your own service, or maybe doing a query to Bing Map services. This is just a hint to try to give somebody a single location, because yeah. And so the moment everybody's been waiting for is the geofencing WinRT APIs. Geofencing enables this contextual automatic experience where we can start these actions based on some location notifications. This is great. This allows us to tell the user, hey, you're near this restaurant, or you're near the zoo, or I see you're near work. Did you remember to wear pants or something? These are important things that people want to know, and it's great to have these sorts of reminders attached to our applications.
I've done that.
Right, me too.
Yeah.
It's great to have these sorts of reminders attached to our applications, even when our application's not running in the foreground. And this ties into the background that we did in the previous session, where these geofence notifications, they can be received in the foreground, or they can be received in the background. And so now's the moment everybody's been waiting for, which is an architecture diagram.
Yay.
Here's the high-level architecture of how geofencing works. We have our application, we have the location service, and this is a service on our phone. We create a fence, and that registers either a foreground event or a background task notification. And the geolocation takes that and it stores it inside of its geofence storage, and then it uses its geo-tracking service for all applications. It tracks all the geofences at one time. Then when we trigger a geofence for our application, it's going to trigger that task that we've set up that we saw the background task in the previous session. And if the conditions are satisfied, it's going to read that notification detail and run that background task, and we can do something like update our tile or send a toast notification. A geofence has a lot of, this is really exciting to me, it has a lot of really cool, easy to use properties, but you don't need to use any of them. All you need is an ID for your geolocation and a geoshape, which is just a geoposition and then a radius around it. Circular geofences are the only ones we support. We don't have geopolylines, but we make up for that with something you're going to see in the next slide. In addition to that, we've got these monitored states. Do we want it to fire when we enter, or when we exit, or when we take away a geofence? Do we want it to use just one time and then make it go away? How long does the user, the dwell time is how long does the user have to be inside that geofence before we actually shoot off the task? And then we can give a start time or duration to our geofence. We say, this is only during working hours, so I want you to start it at 8 o'clock and make it go for 8 hours or 9 hours, or if you work at Microsoft, 16 hours. The tips and tricks. So this is the recommended radius for a geofence is 50 meters or more. You really don't want to create these little tiny geofences because you're going to be dealing with accuracy issues, and it's just easier on the system and for accuracy's sake to have these relatively larger geofences. And this is the exciting part. This is why we think you'll be okay just using circles. Try to keep it under 1,000 geofences per app.
But if you need to go to 20,000.
Right, if you need to go to 20,000 geofences per app, I guess you can do that. One of the really interesting things about this is with 1,000 geofences per app, you could do something like set up a geofence for every major airport in the United States. And then when someone goes into that airport, you could trigger a background task and load a pile of geofences for the area that you're in. And so you can actually create this a whole system that's dynamically loading new geofences, try to keep it lean, and that gives you a lot of power. It's a really powerful way of monitoring the user's location in a really granular way. So you always want to check the time at which the event occurred, because maybe there was a delay in launching that background task, or the dwell time was a little bit off. And please don't use foreground mode and background mode at the same time. We don't want to fire off 1,000 copies. Well, I guess you probably won't have 1,000 background tasks, but we don't want to fire off 3 copies of the exact same geofence. Okay, now the geofencing demo, the moment everyone's been waiting for. I try to lean up my system here by closing all of my applications while my geofence loads up. Okay. So, okay, we should be good here. Looks like I've got all my breakpoints in place. We're actually going to run this on the emulator and not on the device. And part of the reason is because I'm not going to take a camera and run outside trying to trigger geofences. But the second reason is because we've got this really cool location simulation inside of our emulator, and I think it's great to show that off. So let's first create this route. You see we've got a polyline here, we've got our icons. Let's take a look. So now we're going to set up all of our geofences. And so we're going to set these geofences. This is really simple. We showed a lot of stuff about geofences, but creating a geofence is really this simple. We create a geocircle with a position and our desired a size. And then we don't want it to be a single use. We want it to be persistent. And we want to monitor the entered state and the exit state. We create our geofence using all that information and a dwell time of 1 second. And then we add it to our geofence monitor. So now that you've seen how we do it once, we're not going to follow that through for every single one. And now we're going to look at
and we've drawn circles onto the map here just so you can see where the geofences are.
This is not default. This is not default functionality, but we've done it for the purposes of this demo. And now we can load up a route that we want to go through, and we can load these map points from some pre-recorded data files, and we can actually set all these points up. We could set a route up inside of our emulator and then save those out and then replay that in case we want to take a look at that using using that route in a car at the speed limit, or walking or biking, or just doing it really fast because we have no patience. So once we've got our speed limit and our route, we can hit play, and you now see that we're running along. So this is actually the geolocator. I'm going to go ahead and stop that real fast. I forgot that I have a breakpoint around the geolocator, so you can see this is geolocator for both Windows and Windows Phone. Where we create our new geolocator, we got our desired accuracy, our movement threshold, and then we are waiting for that position to change. And when that position changes, we just get to run this position changed event handler. Okay, so get rid of that breakpoint, keep running the application, and we'll try that again. Okay, so it looks like we've hit a geofence. What do we do about it? Well, first we want to read the report from that geofence, and inside that report, we're looking for new state. Have we entered it? Have we exited it? Do one thing if we entered it, another thing if we exit it. In this case, we're going to show some display maneuver. What should we do? This is basically some route guidance that we're going to give alongside our geofence. And so we see as we enter the next geofence, and take a minute here.
So this is putting the route directions out on the bottom of the screen there in that overlay over the map. Now we're entering another geofence.
Yep, and so then
the directions change. Yep. Then we're leaving the geofence, and the car icon comes back again.
Yep.
And that's all driven by the enter and exit on the geofences.
Yep.
So you can make a real nice live display with lots of information happening on it.
Yeah, if you wanted to do something like this, you could run this in a background task, and you could toss up a notification. Let's say you have a geofence and it's gigantic. Let's say it's a kilometer or two around an exit that someone needs to take on a big road trip. You could do something like that, and then it'll just pop up and say, "Hey, your exit's coming up."
It's worth mentioning the location simulation tools in the emulator there. I mean, it's really super cool. I mean, obviously you can go out and write an app or something to record. You can go out in your car and drive around and record the positions. That's one way of doing it.
I've done that.
But actually, but actually, that you can actually there's some new ways of just clicking on points on the map, and it will create a sensible route that's linked to sort of road layouts and things for you.
Yep.
So so they've even made it easier to create fake routes and save them out, and then you can just replay them. And actually, it's worth mentioning when working with geofencing, that using routes like this is a way to go, because the geofencing monitoring software inside the OS has got all sorts of optimizations in to kind of eliminate false positives and to kind of throttle the number of change things. So if you kind of start putting loads of push pins all over the map and the positions jumping around in a random sort of a way, it might well reject those readings and say, well, that's not possible. I'm ignoring that one. So using routes is really the way to go when you're testing this stuff.
Oh, it's extremely powerful, and it's really easy to use. Just open it up and start playing with it. It would be my recommendation. So, okay, so mapping in universal apps. This is a bite the bullet moment. The mapping convergence story is not quite there yet. We're using two different mapping controls.
I like to put it that the phone has converged ahead of Windows 8 at this point. Yeah.
Right. So the Windows has the Bing Maps control. Windows Phone has that Windows Runtime Maps control. Windows is using a location object when it's doing its geolocation grab. Or I'm sorry, when you're putting an item on the map, you're using a location type. And when you're putting an item on the map in Windows Phone, you're using a geopoint type. The events on the map, events happen on the map on the phone and on shapes on Windows 8, and there's a substantial delta between our advanced capabilities and simulations. So is there any good news in mapping convergence at all? Well, yes, there is. The geolocation API is 100% converged. So in the demos, when we actually are doing that geolocation, we're doing it one time and then sending the information out to the two different applications. Geofencing is 100% converged. You're using the same geofencing types and the same geofencing APIs in Windows Phone as you are in Windows.
And this sample you showed, which we're making available, that's got a Windows 8 head on it as well, hasn't it? Windows 8?
If I had a day or 2 or 3 hours to do this, I'd walk through all of these demos on Windows and Windows Phone, because they're all universal demos. They're fantastic.
Yeah, but it's in the sample code.
But it's in the sample code. Download it and go take a look at it. The GeoPoint is also a converged structure, as we saw before, and we can process geodata in a shared part of the PCL. So that is the good news around mapping. And if you're really interested in that, I really recommend go take a look at the demos. So that is a whirlwind tour of geofencing, locations, and mapping controls in Windows and Windows Phone, but mostly Windows Phone. So when we come back, we're going to be covering
Azure Mobile Services and HTTP client, lots of networking fun stuff, and a little bit about authentication with Web Authentication Broker and stuff. So that's a lot of fun as well. So please join us in a few minutes.